Hi everyone. I just wanted to quickly go over the difference between a sequence and a series and then explain a little bit more about converging and diverging for each type, just to show you guys how to answer questions like on the last lesson check this week. So to start off, I just want to remind everyone, a sequence is just a list of numbers that generally follows a pattern. So when you look at a list of numbers with commas between them, you can see if it's approaching a certain number or something like that, and that's when it will converge. Sometimes the sequence can be written in the form of an equation, so you could look at the end behavior, and it would be converging to the horizontal asymptote, which you could find graphically or using your rules for horizontal asymptotes that we learned in the beginning of this year and again in the lesson the other day. Also, a geometric sequence with the absolute value of the ratio less than 1 will converge to 0. So that is always the case, because if you think about it, a geometric sequence is one where you're multiplying by the same number over and over. If that number is less than 1, then the values just get smaller and smaller and smaller, closer and closer to 0. So converge is kind of like a synonym for approach, and so it will eventually approach 0 when you have a geometric sequence with a ratio of less than 1. So that is all about sequences converging. And then if we're looking at series, a series is just the sum of that list of numbers. And so a sequence can be a series and a series can be a sequence. All you have to do is just either add them all up to get the series or just list them all out to get the sequence. And so a series will converge to the sum when it's an infinite geometric sequence with ratio less than 1. That's the only time that we will have a series that converges to the sum for this class. In AP Calc next year, if you take that, you might see something a little more advanced. But in our case, that's the only time. So arithmetic sequences or series will never converge. Those are just adding or subtracting the same number over and over, and they're not going to approach anything. That's like looking at a line, and a line just goes to positive infinity or negative infinity and won't approach anything. So typically we're looking at only rational expressions and geometric sequences or series. All right, so let's do some examples. These 4 questions were the closure from the lesson, but we don't actually do them in the video, and so I just thought I would go through each of these, and that might give you a little clarity on the difference between a sequence and a series and how to determine if and when they converge and what to. Okay, so part A says determine whether the sequence converges or diverges, and if it converges, what does it converge to? And then the series, same thing. So if you look at these 4, the first one is a list, the second one's an equation, the third one's in a list, and the fourth one is in the form of a sum. So you can take any of these and turn them into sequence or series. This first one has commas, but if we turn those commas to plus signs, then it would become a series. Here we have an expression, so I can list it out by doing one term at a time, or I could list it out doing one term at a time and then turn it to a plus, and it would become a series. So that's just kind of how we'll think about it. All right, so I'm going to move on to the first one. We'll do one at a time. And so this one is a list of numbers. So it's a sequence at the start, but we can do the sequence first. I'm going to use blue, like the problem. And it says determine whether the sequence, oh Lord, that was not necessary. Let's see, but I'm doing it anyway. Okay, determine whether the sequence converges or diverges. So first, let's look at this. Negative 22 to negative 35, that's minus 13. Negative 35 to negative 48 is minus 13. Negative 48 to negative 61 is minus 13. And that is arithmetic. Arithmetic sequences diverge. So this sequence diverges. And the series, if the sequence diverges, the series also diverges. If we were to add all these numbers together, it would just be one giant negative number. So both of those diverge. Next, I'm going to have to fix this typo on every page because I had just duplicated it. All right, so number 2. This is an equation, and it is rational, which means that when we look at the sequence, it will converge to the end behavior. And because the end behavior here has 2 variables with the same exponent, 1, it will converge to the coefficients, which I'm going to reduce to -3/2. If we were to graph this, then that would be the horizontal asymptote, and that's what we would see for the end behavior. The series, if I were to take all the values from the sequence and add them up, then I get the series, and the series only converge when they're geometric. Geometric has to have the form a times r to the n-1. You have to see some sort of exponent as a variable for this to be geometric, so I'm just going to write diverge. Number 3, we have a list of numbers 81, 9, 1, 1/9. Okay, so I can tell that this is I'm going to use a different color. Let's go with red. A equals the first term times the ratio, which is 1/9, because I can tell I'm multiplying by 1/9 to get from 81 to 9. And then 9 times 1/9 is 1, and 1 times 1/9 is 1/9. And then we raise it to the n-1. I'm typing, so this is kind of challenging to show. But that is the equation. So for A, let's do the sequence. The list of numbers, the sequence, because the ratio is less than 1, r equals 1/9, then that will converge to 0. When the ratio is less than 1, it will converge to 0. The next number will be 181, and then 1 out of whatever that is, and then continuing, and it will just get closer and closer to 0. So for B, the series, if the sequence is geometric with a ratio less than 1 and converges to 0, which is always true, then the series converges to the sum. So to find the sum, what you're going to do is use this formula, S equals, and then it's the first term. I'm just going to use math, typing math. So you'll be okay. So the first term over 1 minus the ratio. So we decided the ratio is 1/9. The first term is 81. So I'm going to do 81 over 1 minus 1/9. And then that will equal the sum. And that's what it converges to. So I already did that earlier, right here, 81 over 1 minus 1/9, and I got 91.125. And just think, if I were to put plus signs between all of these terms, then this entire expression would eventually equal 91.125 is what that means when we say the series converges to the sum. So 81 plus 9 is 90, 91, 91.111111, and then continuing on until we end up with 91.125. We're going to think of something infinite as having a finite sum, but it does because each value is smaller and smaller. It's like if we were stepping towards the door and going halfway and then halfway and halfway and halfway. The total distance from me to the door is a finite value, but I'll never get there. But it is still a finite value. So that's kind of an abstract idea. But last one. Okay, first of all, this as a sequence is just the equation. This is a sum when it has this notation, but as a sequence, it is just the actual expression, -2/3 to the n-1. That's geometric. 2/3 is less than 1. We ignore the negative. And it's got an exponent to the variable -1. And so that is a geometric sequence with a ratio less than 1. So it will converge. The sequence converges to 0. When the sequence converges to 0, then the series converges to the sum. Now, let's find the sum. The sum formula, as we wrote here, is A1 over 1 minus R. So I'll do that again. S equals A1 over 1 minus R. The problem is that our A1 is not going to be 1 like it looks like. A1 will be whatever we get when we plug in 3. So let's find A1 first. So we're going to do -2/3 to the 3 minus 1. And I did this a few minutes ago in my calculator. Here it is, -2/3 to 3 minus 1, and we get 4/9. So I'm just going to clear that. 4/9. So our A1 is 4/9. Now our sum then will be 4/9 over 1 minus r, which is negative 2/3. It's got a lot of parentheses, but that's how I'm going to have to type it in my calculator anyway. Or I can use the fraction feature. I'll do that. Alpha y equals, okay, we're going to do 4/9 over 1 minus negative 2/3. And so we will get 4/15 for the sum. So that's what it converges to. So I just did that, and that's what I got. 4/9 over 1 minus 2/3. So we would start at 3 at the third term, and then we would just go until infinity. I want to show you guys a little calculator trick for these sums. I don't know how far we went into this in the notes, but if you hit math 0, you get the sum notation, and so we can actually use this to let's start with 3 like it says, x equals 3. And if it says to go to infinity, I just put like 100 up there. That's as big as, if we listed this out to 100 terms, it would be pretty much 0 by then. And then we'll type in the formula they gave us. Negative 2/3 to the n minus 1. Oh, and I forgot the 2, so that's important. Let's see. Second, insert 2. And then if we hit math frac, we get 4/15 just like we got by using the formula. So the math 0 in your calculator is a good way to use some notation to find some of the same answers. I honestly probably did it faster though with the real work. So that's just all I wanted to do. I wanted to go over the difference between a sequence and a series, and then how to tell whether they converge or diverge and what they converge to when they do. Because the lesson check from Thursday, there's a lot of people that missed the series question about converging and diverging and what it converged to. And I wanted to explain that a little bit better. So you can use this video to help you correct anything that you missed from that day. Or just to clear up any confusion, because you know that this type of question will be on your Show What You Know assignment this Thursday. So please email Ms. Bowers or Ms. Pendleton if you have any questions about any of the material from Unit 7. Hope you guys have a great day. Enjoy your weekend. Or if you already watched this after the weekend, I hope it was a good one. Thank you.